Welcome students to the first lecture on determinants. I assume you are all familiar with matrices. In earlier lectures of IIT-PAL, we have discussed matrix in great details. So, I assume that you know that a matrix is a rectangular array of real or complex numbers if A is a matrix, then we denote it by say A11, A12 up to A1n, A21, A22, A2n, like that, A M1, A M2, A Mn, where so the order of the matrix is M cross n, that is there are m rows and n columns, and Aij denotes the element at ith row, jth column position. We denote such a matrix as Aij, I is equal to 1 to m, j is equal to 1 to n, where each Aij is a real or complex number. I further assume that you know matrix addition, subtraction, multiplication and transpose. If you do not remember this, please go back and revise this, how to carry out these operations on a matrix. For this series of lecture on determinants, I assume that you are familiar with this, and with that background I will start what is called a determinant. Corresponding to each square matrix, we associate a number which is called its determinant. So, what is a square matrix? A square matrix is one in which the number of rows is same as the number of columns, or a square matrix can be denoted as A I j, I is equal to 1 to n and j is equal to 1 to n. That means, both the number of rows and number of columns of the matrix are equal. In that case, we call it a square matrix. How is determinant defined? If A is of order one cross 1, that means, if A has only one row and one column, that is A is a constant, say A, then its determinant is A. If A is 2 cross 2, that is there are 2 rows and 2 columns, then we can write A as A11, A12, A21, A22 and its determinant which we denote as like this is equal to A11 into A22 minus A21 into A12. That means, it is the difference of the product of the diagonal elements and the product of the off diagonal elements. For example, A is equal to 1, 2, 3, 4, then determinant of A is equal to 1 into 4 minus 3 into 2 is equal to 4 minus 6 is equal to minus 2. Another example, A is equal to A plus B, C plus B, C minus B, A minus B. If this is the matrix, these are 4 different scalars, then determinant of A is equal to A plus B into A minus B minus C plus B into C minus B is equal to A square plus minus B square minus C square minus B square, which is equal to A square minus C square. A third example, A is equal to cos theta, sin theta, minus sin theta, cos theta for some arbitrary theta, then determinant of A is equal to cos square theta minus sin theta into minus sin theta is equal to cos square theta plus sin square theta is equal to 1. One last example with 2 cross 2. If A is equal to 1, 2, 2, 4, then determinant of A is equal to 1 into 4 minus 2 into 2 is equal to 4 minus 4 is equal to 0. Once we know the determinant of 2 cross 2 matrices, we can develop the determinant for higher order matrices. For example, consider now A, which is 3 cross 3 matrix. That means there are 3 columns and 3 rows. So, let A be A11, A12, A13, A21, A22, A23, or 31, A32, A33. In this case, determinant of A is equal to, we will expand it around the first row. So, I consider A11 and this is to be multiplied by the determinant of this submatrix. That is, determinant of A22, A23, A32, A33 minus A12. I am now taking the term first row second column. As I said, I am expanding the determinant along the first row of the matrix, and this will be multiplied by the submatrix, which we can identify as follows. Since I am taking A12, I will not consider this and will not consider this column. So, what is remaining is this submatrix A21, A23, A31 and A33, and therefore, minus A12 will be multiplied by A21, A23, A31, A33, this submatrix determinant, plus now only one more element is left, that is A13. Therefore, A13 times determinant of the submatrix that we get after deleting the first row and the third column. Therefore, this is going to be, you can easily see, is determinant of A21, A22, A31, A32, which now I can expand as A11 times A22 into A33 minus A32 A23 minus A12 into A21 into A33 minus A23 into A31 plus A13 into A21 into A32 minus A22 into A31. If I expand it further, I get it is A11, A22, A33 minus A11, A32, A23 minus A12, A21, A33 plus A12, A23, A31 plus A13, A21, A32 minus A13, A22 into A31. So, this is going to be the determinant of the 3 cross 3 matrix, which we denote by Aij. I is equal to 1 to 3 and j is equal to 1 to 3. Example, A is equal to 1, 2, 3, 4, 5, 6, 3, 1, 2. So, what is going to be its determinant? A11, which is 1, multiplied by the determinant of this submatrix, which is 5 into 2 minus 6 into 1, minus 2 into, because A12 is 2, 2 into the determinant of this submatrix 4 into 2 minus 3 into 6 plus this is 3, therefore, 3 times 4 into 1 minus 3 into 5 is equal to 1 times 10 minus 6 minus 2 times 8 minus 18 plus 3 times 4 minus 15 is equal to 4 plus 20 minus 33 is equal to 24 minus 33 is equal to minus 9. That is the determinant of this 3 cross 3 matrix. We will work on computing for others, many other matrices in this class, but let me first mention a few points. 1. Is it necessary to expand only along row 1? As you have seen, I have computed the determinant by taking terms from the row and by multiplying it with the determinant of a submatrix and putting the sign plus or minus as per the formula. Therefore, natural question is, do we always need to go along first row? The answer is no. In fact, we can expand it along any row or any column, but we have to be careful in choosing the right submatrix and the sign. As you have seen, in some of the terms we put plus sign, in some of the terms we put minus sign. How that can be determined? The idea is as follows. If we are expanding along the ith row, then determinant of A is equal to, let me write A I 1 multiplied by the determinant of a submatrix, let me call it M I 1, and there will be a sign minus 1 to the power I plus 1 plus minus 1 to the power I plus 2 A I 2, that is the second element of the row, multiplied by the submatrix determinant of the submatrix A M I 2, where M I 2 is obtained by deleting the ith row and the second column from the original matrix. Like that we go, and finally we will write minus 1 to the power I plus n A I n determinant of the submatrix M I n, which can be obtained by deleting the ith row and the nth column of the matrix A. So, the formula is clear. At each point, depending upon along which row we are expanding, we have to take the corresponding submatrices and they have to be multiplied by the terms, but the sign of that will be determined by the row number and the column number, that element of the element on which we are expanding now, and it is going to be minus 1 to the power I plus 1, in general minus 1 to the power I plus j, which is going to be the sign of the product of A I j multiplied by the determinant M I j. So, let me illustrate it. Illustration: consider the same matrix 1, 2, 3, 4, 5, 6, 3, 1, 2, and we computed determinant of A is equal to minus 9 by expanding along the first row. Let us expand along the first column. Therefore, determinant of A is equal to 1 multiplied by 5 into 2 minus 1 into 6 plus minus 1 to the power 2 and 1 multiplied by the element 4 multiplied by the determinant of the submatrix obtained by deleting second row and first column. Therefore, this is going to be 2 into 2 minus 3 into 1 plus minus 1 to the power this element, it is the third row first column element. So, it is 3 plus 1 multiplied by 3 into 2 into 6 minus 3 into 5 is equal to 1 times 10 minus 6 minus 4 times 4 minus 3 plus 3 times 12 minus 15 is equal to 1 into 4 minus 4 into 1 plus 3 into minus 3 is equal to 4 minus 4 minus 9 is equal to minus 9. Let me now expand along the third column. We have A is equal to 1, 2, 3, 4, 5, 6, 3, 1, 2, and we are expanding along the third column. Therefore, determinant of A is equal to minus 1 to the power, this is first row third column, 1 plus 3 into determinant of this sub matrix 4 into 1 minus 3 into 5 plus minus 1 to the power second row and third column, and the element is 6, and I am multiplying it by the determinant of this sub matrix 1, 2, 3, 1. Therefore, it is going to be 1 dot 1 minus 3 dot 2 plus minus 1 to the power third row third column, that element is 2 multiplied by 1 dot 5 minus 2 dot 4 is equal to, this is 1, therefore, 4 minus 15, this is minus 6 into 1 minus 6 plus 2 into 5 minus 8 is equal to minus 11. Sorry, I missed the 3 here, the element. Therefore, this has to be multiplied by 3. Therefore, this is going to be minus 33. It is minus 5 minus 6. So, it is plus 30. It is minus 3 into 2. Therefore, minus 6 is equal to minus 9. Therefore, we can actually see that by expanding it with different row and different column, we are getting the same answer. In order to visualize it for a general matrix, consider a 3 by 3 matrix. A is equal to A 1 1, A 1 2, A 1 3, A 2 1, A 2 2, A 2 3, A 3 1, A 3 2, A 3 3. Its determinant when expanded along row 1 is, as we know, A 1 1 into A 2 2 into A 3 3 minus A 2 3 into A 3 2 minus A 1 2 into A A21 into A33 minus A23 into A31 plus A13 into A21 into A32 minus A22 into A31, which is equal to A11, A22, A33 minus A11, A23, A32 minus A12, A21, A33 plus A12, A23, A31 plus A13, A21, A32 minus A13, A22, A31. When we expand along row 3, we have determinant of A is equal to A31 into A12, A23 minus A13 into A22 minus A32 into A11 into A23 minus A13 A21 plus A33 into A11 A22 minus A12 into A21, which is equal to A12, A23, A31 minus A13, A22, A31 minus A11, A23, A32 plus A13, A21, A32 plus A11, A22, A33 minus A12, A21, A33. Now, if we compare these two expansions, we get plus A11, A22, A33. Here also we have plus A11, A22, A33 minus A11, A23, A32. Here also we have minus A11, A23, A32. Then we have minus A12, A21, A33. Here also we have minus A12, A21, A33. The next term is plus A12, A23, A31. Here also we have plus A12, A23, A31 plus A13, A21, A32. We have A13, A21, A32 minus A13, A22, A31, and we have minus A13, A22, A31. Therefore, we find that instead of expanding it along the row 1, if we have expanded it along the row 3, we get the same answer. For your conviction, I shall now expand along the second column. We had A11, A12, A13, A21, A22, A23, A31, A32, A33. Therefore, determinant of A expanding along second column is minus A12, since second column is this and I am starting with A12, 1 plus 2 is 3, which is odd number. Therefore, minus 1 to the power 3 is equal to minus. So, minus A12 into A21, A33 minus A31 into A23 plus A22 into A11, A33 minus A13, A31 minus A32 into A11 into A23. Since I am using A32 now, the determinant of A11, A23 minus A13, A21, which when we expand we get minus A12, A21, A33 plus A12, A23, A31 plus A11, A22, A33 minus A13, A22, A31 minus A11, A23, A32 plus A13, A21, A32. Let me now compare the results with the one that we got by expanding along the first row. We have A11, A22, A33. Here also we have A11, A22, A33 minus A11 A23 A32 minus A11 A23 A32 minus A12 A21 A33 minus A12 A21 A33 plus A12 A23 A31 plus A12 A23 A31 plus A13 A21 A32 plus A13 A21 A32 and finally minus A13 A22 A31 minus A13 A22 A31. Thus, we see that when we expanded along the first row or the third row or the second column, we get the same answer for any general matrix A. This is not a proof, but you can verify in a similar way that whether you expand it along row 2 or column 1 or column 3, you will get the same expression. Therefore, the determinant of A is the same irrespective of which row or column you have considered for its expansion. I want you to remember the formula for expansion. We have to consider the terms along any row or any column. We have to multiply it by the appropriate by the determinant of the appropriate submatrix, and we have to put the sign properly by considering the element under consideration. If it is I jth element, then its sign is going to be minus 1 to the power I plus j, and then when we expand it, we will get the determinant. I suggest that you verify the same by expanding along other rows or other columns. Now, let us explore certain properties of determinant. Property 1. Determinant of A is equal to determinant of A transpose. For 2 cross 2, we can easily verify consider A, B, C, D. We know its determinant is equal to A D minus B C. If this is called A, then A transpose is equal to A D B C, and its determinant is going to be A D minus B C, that is, it is same. Let us now illustrate it with respect to 3 by 3 matrix. A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Therefore, A transpose is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. You know that we get the transpose of a matrix by writing the ith row as the ith column. Therefore, first row becomes first column, second row becomes second column, and third row becomes third column. So, what is the determinant of A transpose? Let us again expand along the first row. So, it is A 1 1 multiplied by A 2 2 dot A 3 3 minus A 3 2 A 2 3 minus, now I am expanding along the first row. So, it is A 2 1 multiplied by A 1 2 to A 3 3 minus A 1 3 into A 3 2 plus A 3 1 multiplied by A 1 2 into A 2 3 minus A 2 2 into A 1 3 is equal to, if we expand now, we get A 1 1, A 2 2, A 3 3 minus A 1 1, A 3 2, A 2 3 minus A 2 1, A 1 2, A 3 3 plus A 2 1, A 1 3, A 3 2 plus A 3 1, A 1 2, A 2 3 minus A 3 1, A 2 2, A 1 3. Let us compare it with the results that we obtained some time back. This is what we got as the determinant when we have expanded it along the first row. This is what we have got when we have expanded it along the first column. Let us compare the terms A 1 1, A 2 2, A 3 3, A 1 1, A 2 2, A 3 3 minus A 1 1, A 3 2, A 2 3 minus A 1 1, A 3 2, A 2 3 minus A 1 2, A 2 1, A 3 3 minus A 2 1, A 1 2, A 3 3 plus A 1 2, A 2 3, A 3 1 plus A 1 2, A 2 3, A 3 1. So, this term is same as this term plus A 1 3, A 2 1, A 3 2, A 1 3, A 2 1, A 3 2 and minus A 1 3, A 2 2, A 3 1 minus A 1 3, A 2 2, A 3 1. Therefore, the terms are same with the proper sign, same sign, and therefore, the determinant of A is same as the determinant of A transpose. This is property 1. Property 2, determinant of a diagonal matrix is the product of its diagonal elements. By the way, this property is true for all n cross n square matrices, but we are doing here with 3 cross 3 or 2 cross 2. So, let us consider A is equal to A 1 1, A 2 2, A 3 3 and the other elements are all zeros, because it is a diagonal matrix. Therefore, its determinant, if we want to expand it along the first row, it is going to be a 1 1 multiplied by a 2 2 into a 3 3 minus 0 minus 0 times this determinant, which I am not writing because it is going to be multiplied by 0, plus 0 times this determinant, which again I am not writing because it is multiplied by 0. Therefore, all this term vanishes. What is remaining is a 1 1, a 2 2, a 3 3. Thus, if A is a diagonal matrix, its determinant is going to be the product of its diagonal elements. Property 3, the determinant of a triangular matrix is the product of its diagonal elements. For example, consider A is equal to A 1 1, A 1 2, A 1 3, 0, A 2 2, A 2 3, 0 0, A 3 3, then determinant of A is equal to, if we expand along the first column, then A 1 1 into A 2 2, A 3 3 minus 0 times A 2 3 minus 0 times this determinant, which I am not writing because it is multiplied by 0, plus this 0 times this determinant, but that is immaterial because it is being multiplied by 0. Therefore, what we are left with is A 1 1, A 2 2, A 3 3. Therefore, when we are given any diagonal or a triangular matrix, we will not have to bother calculating the determinant by expanding with some first row or first column. We will just look into it and we understand that because it is a triangular matrix, its determinant is going to be the product of the diagonal elements. Property 4, if we multiply each element of a row or column by a constant say k, then the determinant will also be multiplied by k. Or in other words, if A is equal to A 1 1, A 1 2, A 1 3, A 2 1, A 2 2, A 2 3, A 3 1, A 3 2, A33, and we get a new matrix B, say by multiplying the first row with K, then we are elements of B are K11, K A12, K A13, A21, A22, A23, A31, A32, A33. Then determinant of B is K11, Ka11 into A22, A33 minus A23, A32 minus Ka12 into A21, A33 minus A31, A23 plus K times A13 multiplied by A21 into A32 minus A22 into A31. Thus, we see that all the three terms are multiplied with 1 k. So, if I take k to be common, then what I get is basically A11 into minus A23 into A32 minus A12 into A21, A33 minus A31, A23 plus A13 into A21, A32 minus A22, A31, and this is nothing but the determinant of A. Therefore, this is k times determinant of A. Okay, friends, I stop here today. In the next class, I shall explore a few more properties and will try to solve some more problems with determinants. Thank you.